Okay, so today we are going to talk about the next chapter, that is mensuration. Okay, so we have two types. I'll write down the heading first and then we will talk about it in detail. Mensuration. Okay, this is the next chapter that we need to talk about now. This chapter basically has two parts. In the first part, we will talk about two-dimensional figures. And then in the second part, we'll talk about the 3D figures, right? When we say 3D, we talk about cubes, cuboids, prisms, pyramids, cylinders, cones, and stuff like that, right? And when I say cone, and when I say 2D, that we have triangles, then we have circles, we have parallelograms, we have rectangles, we have different polygons and stuff like that. So today we will do some past paper examples which are for 2D figures only, right? So we are focusing on 2D for now. Okay. The most important shape is circle. So this is the most important shape. And now we have discussed the basics of circles when I was talking about angles. Now I'll directly talk about sector. So let's say this is the center of the circle. Then this is going to be the diameter and this would be the radius. Okay. Now I am going to shade the sector in this case. This is basically my sector. Now, obviously, this sector could be made in any part of the circle. I am talking about this one. It could be, somewhere down here. I'll make another one. So let's say it could be this as well. It could be this one too, right? So all these pizza slices, whatever you call it, they are sectors. Okay, I'll write it down properly. This is your sector. We'll just stick to one example for now. So that is a sector. And yeah, now, okay, now we have defined what exactly a sector is. We need to understand how to find the area of the sector and how to find this curved part of the circumference. Okay. So let's start defining everything. I'll be quick. I'll start writing down the formulas. Now, area of the circle. Let's talk about the circle first is pi r square, okay? And the circumference, that is basically the boundary of the circle, is 2 pi r. So these are two formulas that you guys must be familiar with already because they are the most, used formulas, or they are the most popular ones and they are most basic ones as well. Okay. Now I'll talk about area of the sector. Okay. Now, obviously, the sector size would vary. Okay. It could be that this is the sector. This is also a sector. And this is also a sector. So obviously the size is going to vary. So the angle which is making the smaller sector is theta, and the angle which is making this bigger sector is, let's say, theta dash, right? Now we can notice this, that different angles are making different sizes of the sector. So area of the sector Ma'am, when will we do different? Okay, Saeem, I'll get back to you. Okay, don't worry about it. Okay. So area of the sector is going to be theta divided by 2 pi multiplied by pi r square. Okay. This is how we find the area of a sector. So theta would be the angle that is making that sector divided by 2 pi multiplied by pi r square. What is the arc length of the sector? Now, what is the arc length? This line, the part of the circumference, the curved boundary of the sector that is basically part of the circumference is the arc length. So this is the arc length in case of the smaller sector, and this part, this line is basically the arc length of the bigger sector. So again, that is going to be different. It depends on the angle. Theta divided by 2 pi multiplied by 2 pi r. 2 pi and 2 pi would be cancelled, and we have r theta only. Okay. And then the last thing is area of the semicircle. So what exactly is area of the semicircle? That is pi r square divided by 2, because semicircle is half the circle. Okay, and if I talk about the circumference of the semicircle, that would be let me just write it down this way. Circumference just give me 1 second, please. Okay, so the circumference of the semicircle would be 2 pi r by 2, and that would be pi r. Okay, now obviously the statement of the question would tell you what to do. Let's say this is a circle, and if I am interested in talking about the circumference, so this is going to be your semicircle. It is half the circle, and you have been asked to find the circumference of the semicircle. So obviously you will do 2 pi r by 2. But what if the question is find the perimeter of the semicircle? So in that case, you will include the circumference. That would be this side and this length of the diameter. So we'll see how to use the formulas and how to play with the formulas from question to question, right? This thing is going to vary, right? Let's talk about some examples now. So let's Question number 6, example number 1. They want you to find the perimeter and area of the following. We'll do example number 1 and then I'll talk about some more shapes and then we'll do more examples, okay? So I am going to make the shape. So this is a semicircle with diameter 48. This is the center of the circle and you need to find the perimeter and the area of this semicircle, okay? So let's start the working for the perimeter. What exactly is perimeter? Can anyone tell me what is perimeter?
It is the sum of all sides.
Very good, excellent. Okay, so how many sides do we have? We have this curved side and we have the straight side. I need to find the curved side. That would be half the circumference of the full circle. So I can do it this way. Perimeter is going to be 2 pi r. R is the radius, okay? If the diameter is 48, what would be this length? This length would be the radius and it would be 24. So the radius is 24, it is 24. Now 2 pi r would give me the curved side of the complete circle, but I do not have a complete circle. I have half circle. So I'll divide that by 2 and this will just give me the length of the pink side of this type, right? Of this green thing. Now I need to add the diameter in it, that is 48. And the answer is going to be 24 pi plus 48, right? You can find the exact value and this is going to give you the perimeter of the shape, right? Anything that you did not understand, Turhan and Saneem?
It's
No.
clear.
Okay. In case of area, that's very simple. We'll do it quickly. So area is pi r square. It would be 24 square and divided by 2 because we have the semicircle, right? So this would be the area. You can simplify this and the answer is going to be 24 square. Okay, so it would be 288 pi, right? Okay. So this is how we find perimeter and area. Now, this was the most easy example. Now that is it for the circles. I'll stop sharing the screen and I am going to share another screen where I have some more shapes and information about those. I did not want to, write all this down because that takes time. So I've just used some slides for this. Okay. I've shared it. Are you guys able to see it?
Yes, ma'am.
Okay. Now we are talking about 2D shapes, right? So we have circles, we have squares, rectangles, triangles, parallelograms, and different polygons. In case of a square, in order to find the area, this is what we are going to do. Just give me 1 second. It should be L square, okay? So we multiply length with length and that gives us the area. So that would be L squared. Area of a square is L square. Square has all sides equal. So if you have any of the sides, just multiply that with itself and that would give you the area. That is simple. The perimeter would be the sum of all the sides. So L plus L plus L, or just do 4 multiplied by the length. Okay, that's simple. In case of a rectangle, in order to find the area, we do length into breadth. In order to find the perimeter, we do 2 multiplied by length plus breadth. Okay. Now, in case of a triangle, in order to find the area, we do 1 by 2 base into height. Okay. So we do this for such triangles, and even if we have something of this type, this is going to be a right angle triangle. So we pick up the base, pick up the height, and we find the area using the same formula. But what if you have some other shape of the triangle? Let's say we have this shape, and this is not a right angle triangle. Yeah, it looks like a right angle triangle, but what if it's not a right angle triangle? So I'll make it look like that one. So one way of doing this could be that you find the height and then you calculate the area. But let's say you do not have the height. You have two sides. Let's say this is A and this is B and this is C. So you have two sides, let's say A and B, and you have this angle C. So we can use another formula that would be area equals 1 by 2. Any two sides that you have, it could be A, C, it could be it could be B, C, it could be C, any sides, right? Multiplied by sine of the angle that is opposite to the third unknown side. So that would be sine C. You will see in today's class when we will do some past paper questions, we will be using this formula, right? So 1 by 2 A into B sine C. This is the formula that we use most of the times. But if you have a triangle that is not a right angle triangle and you do not know this height, so if you have any two sides of the triangle and the angle opposite to the third side, just use this formula and find the area. Anything that you did not understand in this part? Yes, Saneem and Turhan?
It's clear.
Okay, very good.
No, ma'am.
Okay. Now for the perimeter, obviously we add all the boundary sides. So we'll find this side, we'll find this side, we'll find this side, and we'll add up these sides, okay? Okay, now we are done with the circles already. The area of a circle is pi r squared. The circumference is 2 pi r. Semicircle is half the circle. So pi r squared divided by 2 and 2 pi r divided by 2. Now that depends. If your circle has this line, it could be that it is something of this type. Yes, the perimeter of this figure would be 2 pi r by 2. But if it has this black solid line, then it is going to be 2 pi r by 2. That would be pi r plus d, okay? Because this is also the side of the semicircle, okay? But it totally depends on your question. So be clear with the concept of the parameter. Okay, now this is a parallelogram. In case of parallelogram, we have two pairs of parallel lines. So these two lines are parallel and these two lines are parallel. How do we find the area of this? We do height multiplied by the base. So that is how we do it. And in case of the perimeter of this, obviously we are going to add all the sides, okay? In case of the trapezium, the area is 1 by 2 A plus B. Let's say this is B. So we have two parallel sides, that is A and B. We do 1 by 2 A plus B multiplied by the height. That would be the area, and perimeter would be sum of all sides. Okay, that would include A, B, and these two sides. All right, so we'll do these questions in a bit. But are you guys clear with all the formulas and everything? Any doubts with that? Anything that you did not understand?
No.
No, ma'am.
All right, okay. Just give me 1 second, please. And then I'll talk about the questions. Okay. Let's talk about the very first past paper. So it says AC and BD are the diameters of the circle. So that is obvious. This is the center, that is O, and AC and BD are going through the center and they are touching 2 points of the circumference. That is how we define the diameter. AC is 12 centimeters. So AC is 12. I'll just write that down. And AOB is 130. All right. So the angle AOB is 130. They want us to calculate the area of AOB. Okay. Now, one thing is certain that if AC is 12, BD would also be 12 because that is also the diameter. Okay. Now, what would be this length and this length? Can anyone tell me?
6 and 6.
Very well done. Excellent. So it is 6 and it is 6. Okay. Now this time around, as I told you earlier as well, this is basically a triangle, but it is not the triangle. It's not the right angle triangle and we do not know this length. Okay. So it's better to use the formula directly that I've just shared with you. That was 1 by 2 multiplied by the two given sides that are 6 and 6 into sine of the angle opposite to the third side. This is the third side and the angle opposite to the third side is 130. So sine of 130. So can you guys please tell me the answer that you are getting after the simplification?
13.78.
Just give me 1 second, please. All right, very good. That is correct, 13.78. And we can write it as 13.8. Saneem, Turhan, are you getting the same value? Yes, Turhan, are you there in the class?
Yes, ma'am.
Okay. The next part says calculate the area of the sector AOD. Where is the sector? Okay, here it is A, O, and D. So I am going to rub this and now I am going to focus on AOD only. So I am interested in finding out the area of this sector. Okay. Now, how do we find area of any sector? Okay. So we have a formula. We need to use the formula. I'll write down the formula first. So it is theta divided by, now it's your choice. You can do theta divided by 2 pi if the angle is in radians, or theta divided by 360 degrees multiplied by pi r square. Okay. Now this is completely your choice. Now we have two unknowns and we need to plug in those values and then we would be able to find the area of the sector. What is theta and what is r? I'll just label that on the diagram and I want you guys to tell me. This would be the theta and this is going to be r. Okay, so we already figured r out. So Turhan, can you tell me the values of r and theta? Because we have done angles now.
Yes, ma'am.
Yeah, can you tell me the value of r and theta?
So the radius is 6
Very good. Okay, and theta is? Think about it, take your time, that's not an issue. Meanwhile, I'll plug in the value of R. Yes, Turhan? No? Okay. Yes, Saneem, your answer is correct. Very good. Okay, look, Turhan, that's completely fine. Since you missed angles, maybe you're not able to figure it out. That's why. But it's okay, okay? Look, if this angle is 130, this angle would also be 130 because they are vertically opposite. So this would, oh, this is not readable. Okay. This would also be 130. All right, that is right. So I'll write it down as 130. Okay. Now this angle and this angle, they are equal because they are also vertically opposite, right? These two angles are equal. So let's say that is theta. This one would also be theta. Now 130 theta, 130 theta. What exactly is that making? That's making a circle. Sum of angles in a circle is 360. So what are the angles? We have 130 plus theta plus 130 plus theta, and that is going to give me 260 plus 2 theta, and this is 360 equals that, right? So theta is going to be 50. You just need to simplify this, and this is what you are going to get for theta. Are you okay with this, Turhan?
Yes, ma'am.
Okay. So it is going to be 50 degrees, okay? Now we have everything, we just need to plug in the value of theta and we can just find it out. All right, so this is 50, and now I can just find it out directly. 50 into 365 divided by 360. Okay, can anyone tell me what exactly is the answer?
15.7.
36 into 5 pi divided by 360. This is 1 time. This is 10 times, 1 time, 2 times. This is pi by 2. Okay. Yes. What is the answer?
I got
Yeah.
1
Okay. Okay. This
point.
is 50, and this is
Yeah.
going to be, yeah. Okay. So it is correct. You guys are telling me right. The answer is going to be 15.7. Very well done. Excellent. Okay. That would be the answer. Okay. Let's read the third part. Calculate the percentage of the area of the circle that is shaded. Okay. Now I'll rub the shading that I did. And yeah, now they want you to calculate the percentage of the shaded region. For that, we need to have the area of the shaded part, and then we'll divide that by area of the circle, and then we'll multiply that by 100%. That is how we find percentage, right? Okay. Now I'll write down the areas. So we have calculated the area of the triangle AOB, and that turned out to be 13.8. So this area is 13.8, and the area of DOC would also be 13.8, right? Because both these sides are same and this angle is also same. So the area would be 13.8 as well. Now, what would be the area of this part and this part? Can anyone tell me, please? Okay. Now we have calculated the area of the entire sector, okay? And the area of the entire sector was 15.7. What if I subtract the area of this triangle from this 15.6? I am going to get the area of the shaded part, right? So what is going to be the area of this triangle? So this side is 6 and this angle turned out to be 50. I am going to use the same formula. 1 by 2 multiplied by, this is also 6, both of them are radius. 6 into 6 into sine of 50, and that is giving me the area of the triangle AOD. So it would be 36 into sine 50 divided by 2. Yes, so what exactly is the area?
13.8.
Okay. This is 13.8. And what about this one? This circle is just like the other circle. This angle is also 50. The two sides are also same. So this would also be 13.8. But we are not interested in this 13.8. We are interested in this shaded region. So we need to subtract the area of the sector and the area of the triangle to get that, right? So the area of the sector was 15.7. 15.7 minus 13.8 is giving you what?
1.9.
Very good. So this is 1.9 and this is also 1.9. Now I'm going to rub the extra areas and we'll just talk about the important ones, right? So we have the 4 areas. Let's find the sum of the shaded region. So that would be shaded region equals 13.8 multiplied by 2 plus 1.9 multiplied by 2, and that is giving you 31.4. Very good. Turhan, can you tell me the percentage now? If this is the shaded region, can you find the area of this entire circle and find the percentage, please? I'm waiting uh, for an answer from you.
Okay, so you said that the shaded area that we found, AOD, it's 31.
Yeah, the shaded area of the circle, like all the shaded areas, is 31.4. The question was to calculate the percentage of the area of the circle that is shaded. So shaded is 31.4. Yeah, so how do we calculate the percentage, Turhan? Please calculate that.
Okay, so yeah, we can calculate the percent. We can calculate the area of the entire circle first,
Very well done. And that
which
would
is
be
pi r square.
excellent. So it would be area of the circle, pi r square, and what would that be?
That is 113 approximately. 113.1.
Okay, yes, 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 that is correct.
And then you can divide 31 from that.
Okay, tell me exactly, how do I do it?
Okay, you divide 31.4 by 119.
Very good. And then
113, and then multiply that by 100.
very, very good. Excellent, excellent. Okay. So that would give me 31.4 multiplied by 100 and then divide by this. And that is
27.7%.
very good. 27.7%. Excellent. Okay. Very good, both of you. Let's talk about the next part. Okay. Now this is easy. Now it says the diagram shows a sector of a circle of radius 8 and angle 70. Calculate the shaded region. Now this is very, very easy. We can easily do that. How do we calculate the shaded region of this type? So first we need to find the area of the sector, and then we need to subtract the area of this triangle, and then we would get the shaded region, right? Okay. So let's start the working. Let's find the area of the sector first. What is the formula? The formula is theta divided by 360, because the angle is 70 degrees. Okay, so I will pick up the angle in degrees, multiplied by pi r squared. Now this is the formula. Theta is 70 degrees divided by 360 multiplied by pi r square. So 0 and 0 would be cancelled, and this would become 37 divided by 36 multiplied by pi into 64. Okay, so what do you get after the simplification?
39.09.
Okay, very good. That is
39.1.
39.1. Very good. Centimeter squares. Okay, that is very important. All right. Just give me 1 second. Okay, that is 39.1. Okay, and this is the area of the sector. Now we need to calculate the area of this triangle, and then we do subtract these two. So area of the triangle is going to be 1 by 2. We know the two sides and the angle opposite to that side. This side is also 8. So 8 into 8 into sine 70. So that would be 8 squared multiplied by sine 70. And what is going to be this area? .1 centimeter square. Okay. And now we need to find the difference in order to find this area. So how do we find it? We will just calculate the difference of the two areas. This is 39.1. This is 30.1. And what are we going to get exactly? That would be, yes,
9.02.
yeah, 9.02 centimeters square. Exactly. So the thing is that one thing that I shouldn't have done is, whenever we are doing something for finding the answer, never ever round off the answer, right? So we just rounded off 39 point something something to 39.1, and here as well. So it's good that you keep the answer in at least, let's say, 3 decimal places, find the answer and then round it off. Okay, so the answer would be 9.02 centimeter squares, right? Okay, next we have another question, that is this one. Okay, so it says the diagram shows the net of an open box of height 3 centimeters. Okay, the area of the base of the box is 15 centimeters square, The length of the rectangular box is x centimeters. The total area of the net is a centimeter square. Show that a is 15 plus 6x plus 90 by x. Okay, now apparently they are talking about the rectangular box that is basically a cuboid. That is a 3D figure. But since they have opened that cuboid, that is why I wanted to do this example, because now it is a 2D figure. Okay, so what do we know? I'll just write down as much as I can. This is x. This would also be 3. This side is x, and the height of the box is 3. Okay, so that is given. So if that is 3, this would also be 3. This would also be 3, right? Anything that you did not understand so far?
No.
Okay. All right. So it exactly says the diagram shows the net of an open box of height 3 centimeters, the total area of the base of the box. What is the base? Okay. Are you able to visualize this as a cuboid? This would be the base of the box, and it is 15 centimeters squares. So this area is 15 centimeters squares. Okay. Now using this 15, I can find this side A. I know that 15 centimeters square is basically coming out from A into X. I want A in terms of X, so it would be A equals 15 divided by X. Right? So I'll write down A in terms of X. That would be 15 by X, right? Yes, Saneem and Turhan, did you understand this?
Yes.
Turhan, did you understand this? Please tell me.
Yes, ma'am.
Okay, very good.
Yes,
Now
ma'am.
we
Yes.
need to show that A is this. Okay, what is A? A is the total area of the net. So I will find the area of these 1, 2, 3, 4, 5 rectangles, and then I'll sum that up. Okay, so area of this rectangle would be length into breadth. So that would be 3 into x. Then the area of this one would also be 3x, and the area of the base is 15. That is what they have told us. What about the area of this one? It would be 3 multiplied by, this side is 15 by x, so that would be, yes, it would be 45 by x, right? So the area is going to be 45 divided by x, and the area of this side would also be 45 divided by x. I will use another color to point out the areas. This is the area, this is the area, this is the area, this is the area, and this is the area. I need to sum these up. So A is equal to 3x plus 3x, because we have 2 3x, plus 15, that is the base, plus 45 by x plus 45 by x, and A is going to be 6x plus 15 plus 90 by x, right? So this would be the answer, and we have shown this, right? So are you guys okay with it?
Yes, ma'am.
Okay. Let's talk about another question. So it says, I'll try zooming it more just so it's more readable. I hope it's readable. Okay, I'll read it for you. It says, Graham has one of these open boxes. The total area of the net of his box is 65 centimeters square. Write down an equation in x and solve it to find the length of the base of Graham's box Give your answer correct to 2 decimal places. Now, Graham has one of these open boxes, okay? And I'll rub everything on the box, and the area of his box is 65. Okay, the area of his box is 65 and they want you to find this x. Well, that's very simple. This is the total area. You will just do 65 equals the total area. So that would be 65 equals 15 plus 6x plus 90 divided by x. And now you have an equation with one unknown variable only. You can simply solve this equation and find the value of x. So let's do that together. So that is 65 equals 15 plus 6x plus 90 by x. Okay, we need to simplify this equation first and then we can find the area. Now let me just take this 15 to the other side. So I'll do 65 minus 15 equals 6x plus 90 divided by x, and 65 minus 15 would give me 50 equals. I can take LCM on the right side, so it would be x. I have 1 here, I'll multiply x with 1, and I'll multiply x with 6x as well. So that would give me 6x square plus 90. And now I have two fractions directly, so I can cross multiply them, and that would give me 50x equals 6x square plus 90. I'll simplify this. 0 equals 6x square minus 50x plus 90. Now I can take 2 common just so it looks a bit simple. 0 equals 3x square minus 25x plus 45. Okay, and I've divided that 2 on the other side. Did you understand the step, both of you?
Yes.
Okay. Now we need to find the value of x. So you can try doing it through middle term breaking, but that would be time taking. There's no point in wasting time and thinking about those two numbers. So we directly use the quadratic formula. So Turhan and Salim, can you use the quadratic formula and tell me the answer that you're getting for x? We just have, 45 days left for the exam. So it's good that we start practicing in classes as well, right? So just use the quadratic formula in front of me and tell me the values of x. Yes, sir, Neiman. Okay, I got one message from Turhan. Hmm, very good. And what about the other values? So very good, Saneem and Turan, excellent, both of you, right? So the answer is correct, right? So it would be, okay. Now we are getting two values. One value is x equals 5.7, and then the other one is one value is x equals 5.7 and the other one is x equals 2.63. Now we need to use some basic things and then think about it. Okay, so obviously if this is 3, x cannot be 2.63, right? So x must be 5.7. So the answer is going to be 5.7 centimeters, right?
Yes, ma'am.
Okay, and let's talk about this question quickly. So it says OAB is a sector of a circle with center O and radius 11. Okay, now this thing is a sector, radius is 11 and the angle is 134. Calculate the arc length of AB. So that is simple. We need to calculate this length. I told you how to calculate that. We have a formula and we can calculate it. Okay, so it is going to be theta divided by, now we are going to use the angle in degrees because the given angle is in degrees as well, multiplied by 2 pi r. And yeah, now I need to plug in the values of theta and r. So that would be 134 by 360 multiplied by 2 pi into 11. And what are we gonna get? This is going to be 25.7. Okay, so this would be 25.7. Are you getting the same answers, both of you? This would be 25.7. Okay. Yes, Saneem and Durhan, are you getting 25.7 as well?
Yes.
Okay. Then it says
Yes, ma'am. I am.
okay. Calculate the shortest distance from O to the line AB. So they are talking about this line basically, right? They want you to calculate this red line. Now, obviously, we did not talk about trigonometry, like we did discuss the trigonometric ratios, so yeah, we can do it. Okay. Now, Turhan, you were absent in those classes, so basically we talked about some properties in case of circles, and there was a property which said that if we have a line that is coming from the center and then we have a chord of this type AB, and if this line is perpendicular, these two are going to be equal, right? Also, the angle 134 or whatever angle it is, that would be bisected. Okay, so since that is a bisection that is dividing the length, since it is dividing the length AB into two parts, it must divide the angle in two parts as well. So the angle would become 134 divided by 2, right? Whatever it is, it would be 67. So now we know that this angle is 67, this side is 11, and we need to find the red height. So can we use cos for this? Cos 67 is base over hypotenuse. Base is basically going to be the red line. So I am going to write x for that, divided by 11, that is the hypotenuse. So I'll do 11 cos 67 and that would give me x. So x is going to be 4.29. Yes? Is this okay, both of you?
Yes.
All right. So that is it for today. I'll stop the